This is the second part of the video on transformations. We're on page 4 now, reflections. There are two types of reflections. The first one, the one we're familiar with, a reflection in the x-axis. It's easier just to start with a parabola, y equals x squared. Here we have the reflection, and that will be y equals negative x squared. The change in function, reflection in x-axis. In terms of parabolas, opens up or down. If you look at it, hard to tell with parabolas, but the domain, no change. Usually. Range will change. Then we could get the other type of reflection, which would be in the y-axis. And in this particular case, I'm going to use radicals. If you reflect in the y-axis, then the end result looks like this. Now the negative will be inside the bracket. If we were using an exponent instead of the radical, I'd have means the same thing. Now look at the domain. So this will change. The range, no change. Again, usually. So let's do some examples. In the x-axis. Now this point, and this point are on the x-axis. So they don't get reflected anywhere. They're in invariance. This point here is at 1, 2, 3. It's going to be at -3, directly below. This point's at -2, it'll be directly above. So we will get this. You'll notice the invariants are still on my original. This guy, the original, we'll call g of x. This guy will be negative g of x. The negative's out front. If we reflect in the y-axis, there's the y-axis. There is the only invariant right there. This one is at 1, 2, 3, 4. It'll be at -4. Put a dot. This one is above -2. It'll be above +2. Sometimes it's a good idea, especially in these piecewise graphs, to connect the dots as you do it. This one is at +1. It becomes -1. If we've done it right, we should go through the invariant. And that's at -2. This one we'll call m of x. This one, the reflection, is m at -x. The negative is in the bracket. And that takes care of that page. The next ones, we're on page 5 now, compressions or stretch, depending on what term you want to go. Vertical expansion. Let's draw a parabola. Y equals 1x squared. I will get a parabola that looks like this if I have y equals 3x squared. I'll get a parabola that looks like this if I have y equals 1/4 x squared. It does exactly what it says. This makes it go up 3 times faster, therefore it looks skinny. This one goes up 1/4 as fast, it looks fat. This is normal. This one we call, just to help us remember, skinny. This one fat or wide. They're not really fat, they're not really skinny, but they do tend to look like that. The domain. Can change. Range, no change. Usually. Horizontal. horizontal expansion and compression. I'm going to do a piecewise graph, starting there. This is at 4, this is at 2, this is at 1. We'll call it P of X. We could get this. This would be P 2X. You would think if you put the 2 in, it would make it wider. But since it's in the bracket, it makes it skinnier. Then I would get one like this. And this would be P. The 1/2 doesn't make it skinnier, it makes it twice as wide. In this particular case, the domain changes. No change to the range. If we try these examples, this is going to be vertical. This one I will call g of x. I'm going to graph 2 g of x. The 2 is out front, it does it vertically, so instead of being there, it comes down to here, this comes down, so we'd get this. This point and all of these are invariants. This would be 2g of x. Remember, all of these sheets are just a review or an initial look at it. We'll go into detail. This one I'm going to do horizontal. We'll call this one m of x, and I'm now going to try to do m 2x. Should make it skinnier. So instead of being at -4, it's going to go to 2. This one's above 3, it's going to go 1.5. There's an invariant. This one comes to here, and this one comes to there. So sort of hard to see. We get that. This will be m 2x. If this had been 1/2, it would have gone fatter. Last page. Inverses. Inverses in themselves are a type of transformation, and we've already covered this whole section. Parabola opening down will be a parabola opening left. If this vertex had have been -1, 3, this one would have been 3, -1. Swap the x and the y's. In this particular case, the domain can change, range can change. I'll let you do this by yourself. We've already done this section, so that should be it. Thank you very much.